Before we can discuss white balance, we have to discuss the concept of what white light really is. Our brain automatically recognizes what the color temperature of light is. It looks for clues it has learned to identify, common things like flesh tones, or obvious and recognized objects, etc. But a camera doesn't have that brain. We have to tell the camera what color the light is. That process of telling the camera this is white light is called white balance. White balance adjusts the intensity of each of the red, green, and blue signals inside the camera to produce an accurate overall white signal. Because white balance depends on the color temperature of the light, it needs to be done each time the color temperature of the light changes. We will demonstrate this to you in class on Monday. But for now, here's a few examples of what different white balances look like under different lighting conditions. The camera used for all of these pictures has a white balance done indoors under incandescent light at 3200 degrees Kelvin in setting number 1, and a white balance done outdoors under 5600 degree Kelvin light in setting number 2. When shooting outdoors with an indoor white balance, the 5600 degree Kelvin light makes the pictures look blue. The outdoor white balance adds red light to the pictures to correct for this 5600 degree daylight, making the images look correctly colored. Now we're going to shoot indoors under incandescent light at 3200 degrees Kelvin with the same white balance settings. The indoor white balance will look correct, but because the outdoor white balance is adding red light to correct for 5600 degree Kelvin light that's not there, the scene looks redder than it should. Finally, we're going to shoot indoors under fluorescent lights at 4800 degrees Kelvin. The white balance that was done under incandescent light will look a little blue-green, and the white balance under daylight will look a little reddish. The only way to get correct color reproduction is to white balance for the light that you're shooting under. So in this case, under fluorescent lights, you'd need to reshoot the white balance to get the correct colors. Video black is not nothing. It's actually very dark gray or very little white. And so because it's actually white, all video cameras have a black balance along with the white balance. This adjusts the intensity of the red, green, and blue signals to produce an accurate black color. Black balance is performed after the white balance with the same control. And you should think about it like this: white, black, white. Meaning you do the white balance, then a black balance, then a white balance. And again, we will demonstrate this for you on Monday. It's important to remember that white balance must be performed every time the color temperature of the light changes. And this could be moving the camera to a new light source, or it could be turning the camera within a mixed light source. That's the same as changing the light source. And while we're talking about important things to do every time you shoot, another important thing is to record color bars. You only need to do this once before you start shooting for a day or a session. Color bars gives the editor a reference for colors to come in your video, assuming of course that you have white balance correctly each time the light changes. This brings us to the hardest thing for new shooters: mixed lighting conditions. So consider this question: what can we do when we go into a room that has floor-to-ceiling windows and fluorescent lights on the ceiling? We'll talk about this in class on Monday. But to help your thinking out a little bit, try to identify the color temperatures of the various light sources. Which of the light sources can you control? How can you control them? The sensors in a video camera only work in certain lighting conditions, a limited range of amounts of light. So we also have to control the amount of light that's going into the camera. And again, this is another thing your eye does automatically. To control the amount of light, a video camera has a filter wheel with 4 positions. Filter number 1 is clear. Filter number 2 is 1/4 neutral density, or ND. Now neutral density is that one I talked about earlier, which removes all wavelengths of light equally. The 1/4 neutral density filter removes 1/4 of all the light. Filter number 3 is 1/16 ND, which removes all but 1/16 of the light. And filter number 4 is 1/64 ND, which removes all but 1/64 of the light. The easiest way to remember that is if it's too bright, use a higher number filter. Now some practical examples. Here's an image shot with a clear filter, filter number 1. Here's the same image shot with a 1/4 ND filter, filter number 2. And again with filter number 3, and again with filter number 4.